We have an exciting session ahead. Let us begin without any further delay. With a loud round of applause, let us welcome our distinguished speaker for today's session, Professor Srikanthan Sridharan. Professor Srikanthan Sridharan is a professor of the Engineering Design Department. He earned his PhD in electrical engineering from the University of Illinois and has also worked as a power electronics research engineer at Ford Motor Company in the United States before joining IIT Madras in 2020. His research focuses on electric vehicles, power electronics, battery systems, and energy-efficient transportation technologies. We are honored to have someone with such academic and industry experience sharing his insights with us today. Sir, the stage is yours.
Thanks, Srivatsan. I don't know, the introduction seemed quite good. Okay, this is your phone. So can we have the slides come up here? So we'll try to have this as informal as possible, and we have about an hour's time, I think.
Yeah.
Okay. So we'll walk you through what the department is and what we have to offer and so on. It's always good to see very expectant faces and energetic kids here. So I represent the Department of Engineering Design. So we call this as a place where creativity meets engineering to solve real-world problems. If you didn't know, Engineering Design Department is one of the youngest departments here at IIT Madras. Of course, few departments have come up after that. This was established in 2007 when I was doing my master's in the Department of Electrical Engineering here. So this comes about at a time where the founding members of the department thought that the purpose of the department has to be pivoted to more of industry-relevant courses, projects, and so on. So there was a felt need where the theory had to be bridged along to the practical hands-on experience. So today, as we all know, we require engineers and technologists who can combine creativity, technical, and problem-solving abilities. So in Engineering Design Department precisely focuses on this. We have practical innovation that improves efficiency, usability, sustainability, and quality of life. Although this sounds like a very generic statement, if you have chance to visit the department, you can see what's going on in various labs, and also you can talk to faculty members and research scholars. So if you look at engineering design, it's a core of any industry. So for example, automotive, healthcare, robotics, and electric vehicles. Ultimately, when you create a product or a process, it's always an engineering design problem. And this was the reason why we have always had our courses, curriculum, and then the projects tailored to suit these needs. So we want to bridge the gap between ideas and practical application. Sometimes we always say that you walk in with an idea, you walk out with a product. So that's how we want to position our engineering design department. We like to show you the department in just 60 seconds. I hope this video would play. Okay, yeah.
Design doesn't belong to one discipline. Design is an interdisciplinary science where you combine mechanical engineering, electronics, computer science, physics, chemistry, and so on. We do have a wide Design doesn't belong to one discipline. Design is an interdisciplinary science where you combine mechanical engineering, electronics, computer science, physics, chemistry, and so on. We do have a wide variety of labs in the department which give the students training on what are the essential elements that are required for design. In other words, we wanted to bring the joy of engineering. There are two things in this. One is we wanted to give the fundamentals of design as an undergraduate program, and then bring domain knowledge to the postgraduate program. Straight away go to the applications and teach the practice of design through an applied design process or product.
The students have to spend an entire semester in the industry, and with this, they're able to integrate their learning with industrially relevant problems. But the actual process of creating new design requires a special set of skills which we promote in our department.
So that's a nutshell of our department in 60 seconds. So we'll move on. Okay, now comes an important part. So in terms of the theory, practical and specialization, you would see that the year one, which is focused on the foundational courses in science, design and programming. And once you move on to year two, you will start taking more advanced courses, computer aided design, mechanics, electronics and control systems. As you would see, this is unconventional, where we have courses from multiple areas, imbibing from mechanics as well as electrical engineering. And you would see that in year three, there's a little more deep dive on design. You have mechatronics, system design and foundational courses on specialization. We will talk about the specialization a little further into the presentation, but once you make a choice, then you can start taking core courses based on a particular specialization. And one of the unique things about the department, which is not there elsewhere, is that we have a 6-month industry internship, where you do a project in the industry for an entire stretch of 6 months. Now, coming from an industry, I had a good amount of industry experience. I know that this is a very valuable time period, because a 1 month or a 2 month internship generally is not quite very helpful, because by the time you settle down and get introduced to what they are doing, what projects you get involved in, the time is already over. But 6 months gives you a good amount of incubation period to immerse in the industry and see what you like to do, and probably also what you not like to do also. It gives a certain clarity of what you want to do further going forward. And the 5th year is what we call as a DDP. It's the dual degree project, where you'll also do some specialization courses along with some focused electives. So we had this curriculum task force which happened in 2024. So I was also part of it, representing the department. So the core and the elective credits come to about 524. And since this is a 5-year program, you have the 9th and the 10th semester also. So the curriculum will be based on the master's specialization that is taken. We will now move forward to see what these specializations are. So let's look at this. The engineering design department offers 2 specializations. One is on automotive engineering, the other is biomedical design. In addition to that, we also have what are called as interdisciplinary dual degree programs. We call them as IDDD. And the Department of Engineering Design hosts 2 IDDD programs, which is the robotics and electric vehicles. Of course, you all know that these are some of the very important areas for today. Robotics is finding applications in so many places, and electric vehicles is already there. So it is going to become more and more mainstream, especially with the Indian situation. And as you can see, the HOD says that with the distinctive emphasis on both design and form design and functional design, the Department of ED remains the only interdisciplinary department in India with such a unique focus on domain expertise. So you will see that, interestingly, this department has faculty members who have expertise in wide variety of engineering disciplines. We have faculty members who have had their professional training in mechanical engineering, electrical, electronics, communication, materials, computer science. So it's a vast array of expertise you have. So typically when students do their projects, even at the undergraduate level, when you join, you want to sort of pivot to some area, you find something interesting, you can actually approach the faculty and find a project guide, and you can just get involved in the lab also as part of your undergraduate program. So that's a unique addendum to our Department of Engineering Design. So I also want to highlight some of the important labs, because you can see the range of labs that are there in our department. We are also adding more and more labs, because we have recently introduced certain master's program also. To support that, we have opened up some more labs. So creative design and 3D modeling lab, geometric modeling and CAD lab. This is something that you would do in your first year. And then once you get into electronics courses, as I said, in the second year, you would start doing the analog and digital electronics and control systems lab. So these are all labs which are specifically designed to support the theory courses that you would do. So in a nutshell, the Department of ED is not only interested in just imparting the theory, the lab curriculum is also focused towards hands-on experience, and also sometimes towards product design also. And then in your third year, you move towards mechatronics system lab, which is the lab course offered for mechatronics system design. It's a very important lab. This is where interest picks up in robotics, because we have projects which are dedicated for pick and place. There you understand how to program a controller, and how would you use a sensor, how would you take the output of a sensor and communicate to the controller. So these kind of very practically relevant inputs you would get from these courses. And then this is where you start deciding where you want to move towards. Now you would have done some general courses, then you would decide whether you want to get into automotive specialization or biomedical. So we have a mix of both. Both are equally popular in the department. And depending on which you would now take automotive systems lab and biomedical engineering lab. Electromagnetic compatibility is also a course which is done by everybody. Today, product design is not just packaging something. So it has to go through several tests and standards, correct? So in the department, we offer a unique course called as electromagnetic design and compatibility, wherein once you make the product, you have to test it for whether it meets a certain standard. So all the theory and also the experiments are geared towards that. And then robotics and automation lab, if you choose robotics. And e-mobility is something which is very much focused these days, so our department has also jumped into it. We have a master's program already in electric vehicles. We also have the interdisciplinary dual degree program, as I talked about before, on EV. So you have this EV engineering lab where you actually get to work on the vehicle. We have brought the vehicles into the lab, and you can actually tear them down. So you can study different parts of the powertrain, you can see the power electronics there, motors there, and how you communicate between different components, and then dedicated lab on motors and controllers. So since I am from this area, we have established lab on looking at what are these motors, why are certain motors popular today in electric vehicles. I'm sure some of you are following all these information online. And we also have battery engineering and charging lab to support the EV programs. Now, as far as the industry exposure goes, we have students building so many. In fact, they involve with senior students or even senior research scholars, where they build components and products in the lab. They also participate in several competitions. In fact, ED has a good number of students who participate in campus-wide competitions like the solar vehicle and Agni Rath, that's the solar vehicle, and also Hyperloop and so on. So these are very interesting for ED students because they would have gone through a wide array of courses. So they can now get involved in any of the mechanical design or electrical. They become now easily absorbable in any stream. And as I said before, the 1 semester long industry internship is something unique to our department. So when students apply for these companies, the companies interview them. It's like a proper placement process for these internships. So they go out and they are evaluated both by the faculty and also the industry experts. So, okay, this is only a picture. And I'm sure that you would have seen there are several success stories from the ED department. Being one of the youngest departments on campus, we have had several startups. So I am already looking at people who are looking very eager, perhaps the next great idea, the next startup that can come out from here, we never know. So you might have heard of Aether Energy, Predible Health, which is in the medical space, and Shira MedTech, Crawley on Innovations Lab. So you can see the different areas in which startups have come up. And we also have students, once they graduate, work in a wide array of industries, automotive, EV and biomedical robotics. So exactly catering to what we offer as programs in the department. Software development, product development. Of course, we also have students who figure out that their heart is in consultancy, so they can also branch out towards that. So we would like to play a video on the success story that we have had before. So let's listen to this. We may have to.
Hi, I'm Natasha. Welcome to India.
idea of this Aether started not after they left the college. They designed this on paper even when they were in college. What they lacked is a sort of an atmosphere to bring these two things into a product. And this department, I'm very proud to say, is able to give that kind of environment so that that will be realized as a product. The unique features of the department is that each course is linked to a laboratory. Many of them are unstructured labs, which means that you do a project in the lab. We thought that we should bring this joy of engineering to the students, that they would ultimately feel that they are doing engineering.
It all started in a very humble manner inside a lab on a floor mat, and so where they just had all the tools scattered, and then we used to work there day and night.
That place was almost like home in the department, and that's where we came to when we came back. Build the first few concepts, battery packs, all of that stuff there. So after a few months, when we started hiring people, that's when we realized that we can no longer camp in these areas in this way. Once our ideas reached a certain level of maturity, that's when we went to the institute, we took up formal incubation, and took up our first legit office space in the research park.
They were severely focused on building product. These guys had 4 prototypes within a 12-month period, from the time they got 5 lakhs in funding through their professor.
A smart startup is one who recognizes that by definition a startup is resource constrained. So if there are resources available, you're almost incumbent upon you to use them smartly. What Aether has done is done a great job with doing that, and now we are trying to use that model to say how can we increase the way we support others.
Young guys who wanted to change things, They said whatever is available currently in the market is not good enough. We want to transform the whole thing.
1st of January, we had 4 people in the office, and we started actually designing the first vehicle as a company. We started becoming aware of certain engineering concepts which goes into a vehicle, the practical aspects, what can go wrong, what can go right.
Connecting the first battery management system, that took us like 2 weeks just to connect one piece of circuit onto a battery pack. But the minute it did connect and the readings were right, it was such a beautiful time.
I still remember the early days when they were here, and it was just a naked vehicle, and people were just used to take a ride around the research park campus. And even in those days, there were wonderful comments. I think the vehicle has come a long way.
Aether was probably one of the first startups to get a direct investment from an alumnus in its early stage. This was one of the first companies that we assigned a mentor.
The growth of my
All right, you are welcome to watch that. Do you want to play them full or?
We'll share it.
Okay, we'll later share it with you so that you are able to see them later. And okay, another interesting aspect. What next after you graduate from the Department of Engineering Design with a dual degree in your hand? So there are students who actually pursue higher studies, who actually go for masters and PhD, and people who join the industry, of course, core, tech, and consulting, that always remains. There are people who startups, as you have already seen. We have students who have the spark of an idea. Some of them tend to stay back a little more and then try to work on their startup. There are several of our ED students that I already know. And some of them take to deep research also. And looking at the placement scenario, so you will see that around 42% end up in the core, which is the engineering and the technology part of the job, and the analytics part, which includes software, consulting, data science, finance, and others, about 58%. So although we would like to see a little more percentage on this side, but students' interests are what they are. But the department offers a very solid ground for you to get prepared for innovation, deep research, and so on. So it may be a fallacy that you might think there are so many courses from so many across, it looks like it's a potpourri of several courses. But the truth is that you are able to deep dive into all these courses because you have an immersive period of about 5 years. Once you start seeing that a certain interest catches you by the end of your 4th semester, then you already decide your specialization and you take courses accordingly. And there are a whole lot of electives. So this ED department is very elective friendly. You have so many elective courses that you can take. And then even across outside the department also, so that you have, if you want to get more in-depth knowledge about a particular subject, you're always welcome to do elective courses there. So That's all I think we had to say. If you have any questions or doubts, we also have the student representative, Om Bora and Srivatsan also, who are there to assist me in case I faint here. So we are quite young and energetic students. And the department also is quite young, literally and figuratively, because the faculty members are also quite young. So you're very easily approachable. You can talk to them anytime. So even offline, if you have any questions, please feel free to reach out to any of us. So, what was the last statement that you made, ma'am? Why will they prefer EDs? What? Okay. In fact, several industries want their engineers to be industry ready. So you would see that the Department of Engineering Design already offers courses not only on form and aesthetic design, we also have product design courses. So they are more aware of how the final product would look like. So in a way, it's actually a plus point that they would like to have somebody who has a broad, because in the industry, it is not a domain of just one type of engineering. So even when I was part of Ford Motor Company, although I was trained as a power electronics and motors engineer, the problems that we had to do was not just we had something from the chassis, there was a mechanical vibration, it was tied to some electrical resonance. So this kind of, I think, approach is very important if you have to solve the problem more holistically. So in my humble opinion, I feel that the industries would tend to prefer a wholesome engineer than just extremely focused in only one small area, because we are talking about the joy of engineering and also creativity and innovation. That comes when you have an idea of a multitude of topics. That's why you would see scientists or people like, I'm sure you would have heard the word polymath. How many of you know what polymath means? Okay, very few people. Okay. It has nothing to do with math. It simply means that people who are capable in diverse areas, like Leonardo da Vinci and so many scientists, J.C. Bose, so many people who worked not in one domain. Da Vinci worked in not just mathematics or not just physics, not just a painter, not a sculptor. So he had, that's where I think true genius will come. So I feel there is more preparation towards that. So industry would prefer somebody who is more wholesome like this, is my opinion. If our students want to add anything.
I'll also like to add it in a slightly different perspective. So when like listening to the question, you say, why will industry prefer engineering design students over mechanical and electrical? I seem we are losing the essence why we have engineering design. Like mechanical students are very well versed when it comes to the mechanical part. They have a very deep understanding of how exactly and every machine is working, right from the maths to like every single component. Similarly, for electrical, they have a very well understanding of where exactly what's happening in any of the electrical component. But when we are speaking of working in a company to develop any product, like these two guys cannot sit together and make a product. They'll have conflicts. And like slowly, these people start collaborating, and therein then after some time when they become manager or so, they are in a position when the electrical engineer also has understanding of mechanical, and then they are able to well collaborate with each other. So instead of that, that's what we are doing here. Like right from the very start, we are well versed with the like lot of diversity and all the concepts that when we go there, we can add our unique collaboration to the team. It's not like we are replacing the electrical guy or we are replacing the mechanical guy, but rather we have our own unique contribution that we don't see yet. Yes, please. Sorry? Yes, we have a, like IIT Madras as a whole has some 8 to 9 entrepreneurship like helping facilities. So one of them is incubation center that we have in Research Park. And after starting in the campus, after working their way through, later they took an incubation in Incubation Park, incubation cell we have here.
Can we choose some other department for IEEE, like data science or something?
So there are lots of opportunities.
Repeat the question so that it is audible to you.
Okay, so her question was, what are the opportunities and departments we can get for IEEE? Frankly speaking, even I don't remember the list. There are like 15, 16, so there is a huge variety. If I just have to mention a name of you, so you can start anywhere from like ML, data analytics, quant, and on the other side to robotics, then so it's like actually a very wide diversity. And after figuring out, like you take IEEE at the end of your 2.5 years, like after your 5th sem. And by that time you are very well versed, and then you can choose what do you want to do. Like if you really want, you can just check out on the browser, there is a long list. Please. Yes. Okay, so like as we know, like engineering design is a 5-year course because we offer both BTech and MTech. So what is IEEE? You start with, let's say mechanical engineer, for example. So a person in mechanical engineering, by the 2.5 years, he has done only mechanical and all the relevant courses. Like he can for sure opt for any other elective. That's not the case. That's not like a constraint, but after 2.5 years, let's say he take an IEEE. So after that also he'll finish some projects or like some work or courses in mechanical. So by the end of 5 years, he'll get a BTech in mechanical engineering and a MTech in some other domain. So like we had biomedical and automotive. So those are the domains we are getting MTech in. So if we do not go for IEEE, so like the time and the coursework or the projects, everything that they are going to do for that specific IEEE, rather we'll do for automotive or biomedical. Mainly, yeah. Or we can go do any other IEEE. Even we have that option. Like as it was mentioned in the slides also, robotics and so like electric vehicles are like 2 IEEEs offered by the engineering design department itself. Yes, you can choose any of those 16. Yes, 16 or 17. Yes, all. Yes, any. It's like based on the student interest. No, for 5 year only, for us. So when we do IEEE, we are not doing a MTech in automotive or biomedical, that was the option. Yes.
So we have had such situations in the past. It is not as the preferred mode, but on a case-by-case basis, it has still been taken up by the department, and then the department makes a call on student wants to exit, and that can be enabled. But largely people stay because they want to make use of all the 5 years. And in fact, here everybody who goes to the Department of Engineering Design will get the 4-year BTech in Engineering Design, and then the master's qualification could be on the specialization you choose from the department, perhaps automotive or biomedical, or maybe one of the IDD offered by the department, or other IDDs offered by other departments. So there is more flexibility there as well. They can.
Yeah. Frankly speaking, any type that you can think of. Like, it depends on you. Like, there are some core courses for sure. Beyond that, you also have options to take electives. beyond that, you'll also have extracurricular activities, any clubs or whatsoever you'll do. You'll also do your own projects. Let that be a part of course or outside the courses and all. So it's just a matter of your interest. Where do you end up? Like what all you have done, and then where do you want to add the value, and where the company sees the addition is. And based on that, you can literally go anywhere like tech consulting, finance consulting. Someone might also go in law consulting. So like it's a really wide domain.
Any example from your friends or seniors who have done a consulting role, just to get an idea what is?
So like consulting companies, McKinsey and all, they also, people go there also. So if that's like clear example I can give. Yes? Like we have option to take that as a course, like, and get credits for that.
There is a dedicated course called as UGRC, Undergraduate Research Credits. So if the professor agrees, you have to talk to the professor about what is the project about and what are the deliverables. And if it's made very clear that these are all the things that you would do as a part of the course, you would get credits for that. And there is a limit on how many UGRC credits you can get.
Due to time constraints, we'll have like one last question.
Yes, please. Like, I might not be the correct person to answer this, because someone who has done all this and afterwards he is giving a perspective, okay, that might have had been the best way to land up in design, that could have been the correct person. But if I have to give an answer, then I'll just say it's a matter of choice. Like, if someone wants to go in design, like, there's no one stopping a chemical engineer to go into design, but of course, like, if there is a mechanical engineer on one hand who already knows mechanics of the designing and all, or an electrical engineer on one hand, so until and unless the whatever machine or like whatever you're making has a really big chemical component to it, so there are less chances someone from like a company might consider you to give a design or relevant role in there. But of course, like once you get in somewhere, people do often, like from chemical, from electrical, or like any other branches, like by the way they take some experience or spend some years in the company, due to collaborations and all, they do like start going into the design process also. Like by the end of 10-15 years, what will we be doing as any engineer? So we'll be ending up doing a consulting part in our own company. Like people will be there who will be working, but we will have the entire design philosophy in our mind, like how will things will be going, what will be the constraints, how will it deal with each other, and we'll be guiding the people who are actually working hands-on. So like, if I'm going to that path, I don't see like no one stops, but of course it will be kind of harder, I think.
How is it different from biomedical engineering? We also have a biomedical focus in final year.
So biomedical engineering, do you want to answer this?
Like IPME versus this. IPME versus this. I understand this is wider, but beyond that, any other?
Do you want to answer? I don't really have frankly, I don't really have a very good understanding of IBME.
So the biomedical stream offered in the engineering design is more towards products, diagnostic devices, medical imaging systems, and so on. Electromagnetic compatibility is also offered as part of it. So they are more towards product building and also more towards innovation in devices and systems. So that's the core, I would say, the focus and the thrust of the biomedical stream.
You can also attend the IBME session, which will happen at 1 p.m. So I think we'll close the session for now. Thank you, sir. And
next session here.
Aero.
Let's start
Yeah,
with
yeah. So thank you so much, sir, for sharing your knowledge and experience with us. And right now we'll be having aerospace session here. And we also have BS Math, which is a new department in Hall 3. And you can also join us for Electrical Engineering Hall 1. Thank you.
Like in case you want to attend any of these sessions, please carry on. If you want to ask some questions, we'll be staying around.